Assalamualaikum. Welcome back to Sir K Lab Physics Video Lessons for High School Students. In this episode, we analyze another example of projectile motion that requires a quadratic formula to compute the time it takes a body to acquire a given vertical and horizontal displacements. So join me till the end of this video to watch and learn. Question is, a 76.0 kilogram rock is rolling horizontally at the top of a vertical cliff that is 20.0 meters above the surface of a lake. The top of the vertical face of a dam is located 100 point meters from the foot of the cliff, with the top of the dam level with the surface of the water in the lake. A level plain is 25.0 meters below the top of the dam. The resistance can be neglected. Use G equals negative 9.8 meters per second squared. Question letter A. What must be the minimum speed of the rock just as it leaves the cliff so that it will reach the plain without striking the dam? And question letter B. How far from the foot of the dam does the rock hit the plain? We are given the height of the cliff denoted by letter H equal to 20.0 meters. The horizontal displacement, or the top of the vertical face of a dam, is located 100 meters from the foot of the cliff. The height of the dam, which we denote here as y, equals 25.0 meters. In question letter A, we are asked to find the minimum initial horizontal velocity v0 of the rock. And for question letter B, we are to compute the horizontal displacement denoted by x, or how far from the foot of the dome does the rock hit the plane. So for our solution, we start with question letter A. We are given the range big R, but we don't know the time it takes the rock to travel this range. So we use the formula T1, or T sub 1, equal to square root of uh, 2 times y divided by g. All right? Because y is given. This is the height of the cliff. And the initial vertical speed v naught y is understood to be 0. All right? So, substituting our given quantities, t sub 1 equals the square root of 2 times negative 20.0 meters over negative 9.80 meters per second squared. So doing our math, we get the value of the time t1 equals 2.0 seconds. So we can now proceed to find the initial horizontal speed v naught using the formula capital R divided by time t sub 1. All right? So this is v naught equals 100 meters divided by the time t1 equals 2.0 seconds. That is, v naught is equal to 50 point meters per second in two significant figures. Question letter B. Before we can solve for the displacement x, we need to find the velocity v sub y after the time of 2.0 seconds. All right. We can get the value of v sub y using the formula. V sub y equals the product of acceleration due to gravity g and the time t, right? That is, by equals negative 9.80 meters per second squared multiplied by the time of 2.0 seconds. So we get by equals negative 19.6 meters per second. All right? You must have noticed that since we started solving in part A, we have been treating the vector quantities, okay, as vectors with their given magnitude and directions being emphasized, right? So, when the rock is exactly at the top of the vertical face of the dam, its velocity is composed of the horizontal component, all right, b naught, and the downward vertical component, b naught y. So, the value of Vy that we computed here, negative 19.6 meters per second, is now considered as the initial downward uh, velocity, all right? If you're going to consider the motion of the rock, okay, in uh, falling through the height equal to 25 meters, all right? That means at the top of the vertical dam, all right, the velocity of the rock is composed of the horizontal component, okay, and the vertical component, which is downward, equal to negative 19.6 meters per second. So that is denoted here by B sub not Y, right? So we can use the equation Y equals V sub not Y times the time t plus 1 half gt squared, all right? And our goal here is to determine the time it takes for the rock, all right, to hit the horizontal plane. all right, where the horizontal plane is also one of our target variables. So from this equation, the value of y corresponds to the height of the dam, all right, which is also treated as a vector quantity. So with respect to the top of the vertical dam, this y here is equal to negative 25.0 meters. That is, negative 25.0 meters is equated to v sub not y, which is negative 19.6, multiplied by the unknown variable t sub 2, then plus 1 half gt squared, where 1 half g is negative 4.90 meters per second squared, and of course, t sub 2 squared. All right? So our unknown variable is t sub 2, the time it takes for the rock to hit the horizontal plane. And rearranging this equation, all right, and dividing all the terms by 4.90, we come up with this equation. T sub 2 squared plus 4.00 T sub 2 minus 5.10 equals 0, which obviously is a quadratic equation. So in just a little while, we're going to determine the value of T sub 2 using the quadratic formula. All right, so our simplified equation, T sub 2 squared plus 4.00 T sub 2 minus 5.10 equals 0 is a quadratic equation. So in determining the value of the time T sub 2, we make use of the quadratic formula, all right? So the quadratic formula to find T sub 2, all right, is T sub 2 equals quantity minus b plus minus square root of b squared minus 4ac all over 2a, all right? That means T sub 2 is equal to negative of the coefficient of T sub 2, which is 4, all right? And that must be negative. So plus minus square root of b squared, that means 4 squared, and then minus 4 times the coefficient of t sub 2 squared, which is 1, multiplied by the constant 5 point or negative 5.10. All right? Then all over 2 times 1 or 2. So when you simplify, we get t sub 3 equals quantity negative 4 plus minus square root of 16 plus 20.4 all over 2. And further simplification will lead us to t sub 2 equals quantity negative 4 plus minus 6.0 all over 2. All right? So between the two roots, we take the negative 4 plus 6.0 divided by 2, because the other root will come out to be a negative value for t sub 2. All right? That means our computed value for t sub 2 is equal to 1.0 seconds. And so therefore, we can now proceed in determining the horizontal distance x, all right, which is the distance from the foot of the dam to where the rock, okay, lands on the horizontal plane, all right? So we use formula b naught x multiplied by the computed time t sub 2. That is 50 meters per second multiplied by 1.0 second. So we finally get the value of the time t, the value of the horizontal distance x equal to 50 meters, in other words, into significant figures. So this is the final answer to question letter B, where we are asked to find the horizontal distance along the plane where the rock is going to hit. All right? And that concludes our video lesson for this topic. Till the next episode, mabuhay. Masya Allah. Thank you very much for watching. Please follow me in my FB page, Watch and Learn. And please don't forget to subscribe to my YouTube channel.